All right, gang, it's time to start talking about RF, radio frequency spectrum. When we talk about this, really we're referring to the entire range of frequencies that go all the way down to the audio level, which you're hearing right now, which are big, slow waves, to all the way up to gamma rays, which are incredibly fast, high-speed rays, right? High-speed energy moving through a particular system. In between, of course, we have things like the visible spectrum of light, right? We're talking about a spectrum here that goes all the way from audio to gamma, but there are spectrums within those spectrums, right? Roy G. Biv. Did you hear Indigo got rejected? It's as bad as Pluto. Our wireless networks are, well, they're a lower frequency range than a visible spectrum, but higher than, say, AM and FM ranges that occupy the space over here. So what are we talking about when we refer to these waves and the spectrum and frequencies? Frequency of what? Well, a wave can be measured based upon the amount of space that it takes for the wave to complete a cycle. So in order to get from one point to the other and get back again, in space, if you were to measure that wave, is that 10 meters or is that 10 millimeters? If we're talking about something way down here in the audio range, that might be 10 meters. If we're talking about way up here in the gamma ray range, it's even less than that. So rather than measuring the length of the wave, though, what often is more useful is to say, well, these waves occupy space, and they're moving through space, emanating from a source, right? So we'll have a transmitter emanating out. There's our access point emanating out that signal. And then we're detecting that at some point. Here's another access point. So the question is, how frequently do I detect the waveform coming through that static point? How many of those waves can I receive per second? That is what is known as hertz. The number of waves received per second is a value of hertz. So if I say that something in the audio range is 70 hertz, well, I'm saying that literally the waveform is heard by the ear, we'll say 70 times per second. But what occupies our attention right now are going to be things in the gigahertz range. So kilohertz, thousands of waves per second. Megahertz, millions of waves per second. Gigahertz, billions of waves per second. And so when I say that we're dealing with Wi-Fi 802.11b in the 2.4 gigahertz frequency range, what I'm saying is that that access point is receiving 2.4 billion waveforms per second in an incoming transmitted signal. Interesting, isn't it? Now, that is kind of our base level of communication. This is what everything is based on. What's going to be interesting is, of course, that we'll see that wireless networks are a form of microwave, that other things besides wireless networks communicate in a similar place. And, if you have two people talking, what ends up happening if they're talking at the same time at a similar frequency range? Well, then it gets hard to hear, doesn't it? The same thing can happen with wireless. What happens if there's a wall between you and someone else that you're trying to talk to? Well, they can't hear you as well, can they? The wall is going to absorb your signal. So it's important to understand that there are some common principles that we are familiar with in terms of what happens with light or what happens with hearing. Two things that we're very familiar with because we have organs designed to detect those particular frequency ranges that are going to parallel what we see in a wireless network as we deal with receiving these microwave type signals through the